In this video I will describe the DIY uninterrupted power supply unit in more detail. It includes a frame, a battery lock, an input socket, a voltmeter that senses the voltage at the input of this buck-boost converter that provide 12-volt regulated voltage over this cable to power the printer. These are the main components of the unit: the input voltage converter, the battery charger, the output voltage converter, and the voltage switch. The battery lock is made of a notebook display hinge that holds the battery in place quite well. Let's connect the battery and check if it is reliably sitting in place. This is the power supply adapter I use to power the printer and the battery charger under normal conditions. You can use a 12-volt or 19-volt adapter. Just make sure its rating is at least 5 ampere. The higher the current rating, the better. Using a higher current rating power adapter will help avoid overheating of the adapter while it is feeding the charger and the printer at the same time. Now I will connect the adapter to the UPS. As you can see, the voltage at the input of the final converter is about 22 volts. The final converter that feeds the printer always provides 12 volts at its output. Let's simulate a power outage to see that there is always some voltage present at the final converter, whether supplied by the power adapter or by the battery. This is how we achieve the uninterrupted power supply of the printer due to voltage switching between the mains and the battery. This double quick-acting diode does the job. Okay. It's testing time. Mains power interruption. Mains power is back. One hour 40 minutes later. So, now we know it for the original Elegumas. The components of the unit don't get hot during battery operation. But the battery charger and the mains power adapter may get rather hot, while the battery is charging after a long power outage. So, if you envisage long mains power interruptions, you will need a power adapter with about 8 ampere rating. You will also need to reduce the charging current by removing one of these SMD resistors. By this you will also provide an optimal charging current for the battery, as its recommended charging current is about 2 amperes where the unmodified charger provides 3 amperes. The 3 ampere charging current would be good for 2 batteries connected in parallel. To calculate the charging current, divide 120 mV by the charging resistance. For example, by removing one of said parallel resistors, we get 0.08 ohm instead of 0.04 ohm. So by dividing 120 by 0.08 we get 1.5 ampere, which is good enough in our case. To prevent overheating of the charger, I installed a heatsink on the inductor. So here is another test with the heatsink installed. During this test, after about 1.5 hours I reconnected the mains power adapter to charge the battery and simulate shorter power interruptions. The print completed successfully, and we may finish the test and discuss the diagram and the components in more detail. Before we do this, I will completely de-energize the printer. Here are 2 versions of the diagram. The upper version is for 12 and 19 volt power adapters. The lower diagram is for 19 volt power adapters only, and it does not contain an input power converter. You can pause the video to have a closer look at the arrangements. For printers with a mono screen, the battery operation may be much longer, because they use less power, providing more efficient curing thanks to the more UV transparent screen. For example, my Nova 3D Elfin 3 Mini can operate for 3 hours on the battery duration of the test print, with little battery discharge amount. So I assess it can do another hour to a total of 4 hours. Please don't forget to subscribe to stay charged. Thanks for watching and happy printing.